Hello guys, welcome back to my channel Math with Trockers. So today we are looking at mathematical induction considering differentiation. So now we want to do the second problem on differentiation of trig functions. So now first part, it's saying show that sine of x plus pi over 2 is equal to is identical to cosine of x. Hence, proof by induction that the nth derivative of sine ax is equal to a to the n sine ax plus n pi over 2. Right? These are small issues. Okay, so remember the first step, guys, is to prove that identity. Right? So we want to show that sine x plus pi over 2 is identical to cosine x. So when you prove, you come from one side. So my left hand side here, right, it's we want to show that sine x plus pi over 2 is that. But remember, you should know this sine a plus b, when you expand that, is the same as sine a cosine of b plus cosine of a sine of b. This is what we are going to use, right? So in this case, it becomes sine x cos 90 plus cos x sine 90, right? So we want to see what sine 90 and cosine 90 are, right? So in this case, for sine 90, it's what? It's 1. Then cos 90 is 0, right? So we say, so this is sine x times 0 plus cos x times 1, which is just 0 plus cos x, which is cos x. So we have shown what is needed, right? All right. So first part is we are done. But this problem has a hence part. So there's the hence part here. So the hence part, it suggests that we are going to use the result, the above result. So we need to keep this. We need this to prove that. So now let's move on to our induction. So for mathematical induction, right, you know, first step when n equal to 1. So when n is equal to 1, we are proving this part here. So the left-hand side is going to be d of dx of sine ax, right? So in this case, we know that when we differentiate sine, we get cos. Then we use the PTA, power, trig, and algebra. So since we don't have the power, move on to the trig. So that's cos ax. Then our algebra, if we differentiate ax, we get a. So we multiply. So it's just a cos ax. This is what we get, right? Then right-hand side. Our right-hand side, it's now, since n is 1, it's a sine ax plus pi over 2. So we know this from this result. So if you want, you can just apply the above result, or you can just redo this, right? So let me quickly redo this. So it's just a, right? So when I expand, it's going to be sine ax cos pi over 2 plus cos ax sine pi over 2. And we know that in this case, from our, remember pi over 2 is 90, sine 90 is 1, cos 90 is 0. So it's going to be a, right? Since this is 0, it vanishes, then this is 1 cosine of ax, right? So we say, since left-hand side is identical to RHS, therefore the statement holds for n equal to 1. We are done. Now let's move on to assumption. right? Assuming true for n equal to k. So when we assume true for n is equal to k, we are just replacing this n with k. So it becomes d, which is the kth derivative of sine ax is equal to a to the k sine ax plus k pi over 2, right? So now we are done. So we move on to the inductive step. So we state the result when n is equal to k plus 1. So when n is equal to k plus 1, it's going to be this to that. Sine ax, which is equal to a to the k plus 1 of sine ax plus k plus 1 pi over 2. Right, so this is what we are trying to achieve. Okay, so now let's go to the proof stage. So when going to the proof, you can copy this statement. We are going to copy this statement here, which is d k plus 1 sine ax over dx to the k plus 1 is equal to a k plus 1 sine ax plus k plus 1 pi over 2. Right, so I'll deal with left hand side. So my left hand side here. Okay, so my left hand side, it's gonna be d k plus 1 of sine ax over dx to the k plus 1. So always you differentiate the assumption. Right, so I am going to differentiate this part here. That's my assumption. So it's a to the k of sine ax plus k pi over 2. Right, okay. So remember, when we differentiate power, we don't have the power. This is just a constant here. So you keep ak, then if I differentiate the trig, I'm going to get positive cos. So it's cosine, right? A to the, if I differentiate sine, I'll get positive cosine. Then I'll keep ax plus k pi over 2, right? Then times, if I differentiate here, I'm going to get a, which is a to the first. So these two, you can employ laws of indices. Yes. So a to the k plus 1 cosine of ax plus k pi over 2. So now that's where reasoning needs to be done. So I am going to rewrite this, but, right, from first step, we know that sine x plus pi over 2 is identical to cosine of x. So what you can do as a mathematician, you can just, for now, you can say, okay, let ax plus k pi over 2 be identical to x. So that this implies that my k plus 1 derivative here, it simplifies to a to the k plus 1, then cosine of x, right? But you know this cosine of x is equal to that, which is the same as this. So it's now a to the k plus 1, then sine x plus pi over 2. I'll put my capital X. But remember, capital X, right? Capital X in this case is this one, which is my ax plus k pi over 2, then plus pi over 2. Right, we are almost there, which is equal to a to the k plus 1 sine, and this now ax plus, so here I can take out pi over 2 and remain with k plus 1. So it's just a k plus 1 sine ax plus k plus 1 pi over 2, which is exactly what we are trying to remember. This is exactly what we are trying to show here from this result, which is that one here, right? Which is exactly the same. Okay, we can just say it's all over 2 or just over 2 is the same thing, right? So, which is true for n equal to k plus 1. Therefore, the formula holds for n equal to k plus 1. So once we are done, we can give an overall conclusion by saying since the statement since the statement is true for n equal to 1, n equal to k, and n equal to k plus 1. Therefore, by induction, the formula holds for all positive integers n. Then we are done. So guys, mathematical induction is going to be easy, right? We are going to demystify that misconception that induction is hard. No, it's not. With Trockers, it's easy. All right, guys, if you haven't subscribed to my channel on YouTube, on TikTok, and on Facebook, just go ahead and click the like button, subscribe, and share. Thank you so much. I will see you on the next segment. Have a good day.